Okay, so for this lab, we're going to be comparing and contrasting the freezing point of salt water versus fresh water. So as far as our initial setup for this lab, you're going to need LabQuest. We're going to use two temperature probes, two different temperature probes plugged into channel 1 and 2. A plastic spoon, 400 milliliter beaker, two test tubes, our iPad, and we're going to need this double ring stand setup. So we've used a lot of ring stand setups in this class before, but this time we're going to use two of them. And those are going to hold our test tubes so that they're pretty close together. Because eventually we're going to be dropping the test tube into the beaker, both of the test tubes at the same time. So you want them to be close enough together. Alright, so we're going to fill up one of these beakers with salt water, one of them with fresh water. So what you should do, I just took two pieces of tape, labeled them salt and fresh, because you're going to want to keep track of which is which over the course of this procedure. And I'm just going to put them on the test tubes, my labels, just so that I can keep track of them as we go through this lab. So for fresh water, all I'm going to do is fill up about 1/4 of the beaker, like 1.5 inches or 1/4 of the beaker. Just fill it with cold tap water. That's actually probably enough right there. For the salt water test tube, I actually have a thing of salt water pre-prepared back in the fume hood. So again, you're going to want to get about 1.5 inches or about 1/4 of the test tube filled up. Okay, so before we start any of the procedure, this is the very first thing you're going to do. Make sure that your test tubes are filled up. You've got one with about 1/4 of the test tube of fresh water, one with about 1/4 of the test tube filled with salt water. Alright, so I've got my two temperature probes hooked up. Let's set up our LabQuest. So this is going to be a time-based experiment. Our rate is going to be 0.1 samples per second. 0.1. And our duration, we're going to run this for 15 minutes. So 900, we'll set it to 900 seconds here. So rate, 0.1 samples per second, duration, 900 seconds. So I just went ahead and put in my two temperature probes here. I put the first temperature probe into the fresh water, the second temperature probe into the salt water. We're not going to hit play or do anything with this just yet. So the last thing I'm going to do here for my initial setup, I grabbed about half a scoop of ice. I'm going to dump this into my 400 milliliter beaker. So you don't want it to be too full. I got it about half full. And then I'm going to fill it up with just a little bit of water too, maybe between 150 and 200 milliliters of cold tap water. I've got a nice ice bath. Again, you want to fill it maybe about half full. You don't want to get this too full. Take some salt from up in the front. So I've got a couple of these containers up in the front. Be sure to just grab what you need and then bring it back, because I don't have enough containers for every group here. And I'm going to mix in 4 scoops of salt. As soon as we do that, I'm going to hit play on my LabQuest. And as soon as I do that, I want to lower my test tubes into the saltwater bath. So you don't need this to hit the bottom, just enough so that you get the water and your test tubes fully submerged. So this next part is extremely important. As soon as I run my LabQuest, I need to do two things. So this works really well if you're working with a second person. I'm going to start stirring the salt water with my spoon. So you want to stir the salt water with your spoon. We're going to be doing this for the entire 15 minutes. So for the entire 15 minutes, one of you needs to be stirring the salt water. The other partner, I just want you to carefully move the temperature sensors up and down. We're not going to do this for the entire time. So we're going to, again, you're going to stir your salt water for about 15 minutes. And we're just going to bob these temperature probes up and down. We're going to do that for about 10 minutes. So 10 minutes of the trial. We'll come back in 10 minutes to see what we do next. But you're going to be doing this, both of these things for the first 10 minutes here. I just want to show you really quick here. It's been about 5 minutes for me. I'm just going to dump a couple more ice cubes in here, kind of over time as I'm stirring. Maybe add like one more scoop of salt. Now you're going to stop bobbling this, so you don't want to do this anymore. Stop doing that. You're still going to stir for the last 5 minutes. So this is really important. It's 600 seconds or 10 minutes. You got to stop moving this, and we're just going to be stirring for the last 5 minutes here. Alrighty, after about 15 minutes then, your data should look something like that. We'll talk more about that in a little bit here. First thing you're going to want to do, because this takes a little while, the cleanup for this lab takes quite a bit of time, is to pull up your test tubes. So there's a very good chance that your test tubes are frozen over, which means, yep, so it looks like my freshwater one is completely frozen over. That means you don't want to pull these out, because if you yank it out, you might actually break the temperature probe. So while these are warming up, we can clean off our lab station here. All right, so our beaker here, you're going to want to rinse this out quite a few times. I would say 5 times. Same thing with our test tubes. Take off the tape, please. Okay, so I've cleaned off my whole lab station. I'm ready to look at my graph here. So again, should look something like this. I'm going to just go ahead right away here and connect this to graphical analysis. All right. So a couple quick things here. Our red line is our fresh water. So that means our blue line is our salt water. So you can see that the freezing points of both fresh and salt water are totally different. Some things that should stick out here, these little dips in your fresh and then your salt water, that's called a freezing point depression, which is a phenomena that occurs as substances freeze. This is not your freezing point. So this is a kind of a tricky thing to think of, but this right here is not your freezing point. Your freezing point, so for example, the fresh water, your freezing point is going to be right around here, right around 0.3 degrees Celsius. It's when your data stabilizes. So we go and undergo this freezing point depression. And during this whole time that the freshwater and kind of the salt water, but let's focus on the freshwater for now, for the whole time that this remains stable, it's undergoing a process of freezing. So when, matter changes state, during this whole time it takes to change from liquid water to solid ice, the temperature should be fairly stable. The reason that it's not stable, totally stable, I guess, in the salt water is because as the fresh water within the salt water is freezing, the water becomes more and more salty. So you just get the water in the salt water here, over time is becoming incredibly salty as all of the fresh water, the stuff that's not salty in that substance, freezes out. So again, while this is stable here, it's undergoing a phase change. When that phase change is complete, that would be right here. That's when your fresh water can start cooling down below its actual freezing point, because all of the water is turned to solid ice, and the ice can go well below the freezing point. One last thing here before I forget too, make sure that you just wipe off. I've got towels in the front. Wipe off your table, because that salt can get all over the place and it can be really, really nasty. If you leave me a big salty mess on the table, then Professor Rex is actually going to eat you. That's just a fact. Again, please let me know if you have any questions with those last few questions on the lab write-up, or with anything related to the procedure of what we did in this lab. This was our freezing point of ocean water lab. Thank you for watching.